Hello guys, welcome back to the lecture series on pattern recognition. So in the last lecture we talked about error and we saw it for a two class case. So we had only two classes in our previous lecture. So now here we'll see what happens if we take three classes. So let me define a new class. So this is say flower, any flower. I've given it the name, this is class flower. So it looks like this. So a class flower will be something like this, and this is our class sunflower, and this is rose. So the my new made flower looks like this is sunflower and this is rose. So let me denote flower as omega 1, sunflower omega 2, rose as omega 3. So our decision rule still remains the same. We will choose omega 1 if the probability of omega 1 given the vector. So basically it is the same thing. I will have training and test data samples. So after training I will get the posteriori probability. These probabilities I will get. What is the probability that given it is say flower, what density of x I should get. So now x can be a vector also, we saw that in the previous lecture, luminance and size, etc. So given a particular, so in the test phase, so now I am in the test phase when I am testing or using my algorithm to detect things. So I will choose this flower omega 1 if the posterior probability, that is probability of that flower given a particular feature vector of the image, is greater than the other two probabilities. So probability of omega 1 is greater than omega 2 and probability of omega 1 given x is greater than omega 3. This is what I will choose this flower if the probability is greater. Similarly, I can choose sunflower if the probability of sunflower is greater, or rose if the probability of rose is greater. So here my decision rule will be a maximum of all the three. So please note that here I am using argmax. So there is a reason, because the probability say for a particular given image or feature set, I can get say probability of flower is 0.7, say probability of sunflower I got 0.2, and probability of rose I got say 0.1. So when I ignore this, I'll just use max. So I'll get the answer as 0.7. So the maximum probability among this is 0.7. But I'm not interested in what is the probability. I'm interested this probability belongs to which class. So I'm not interested in this 0.7. I'm interested in this 1 basically. So this argmax basically gives you the index which class does that probability belong to. That is why I am using argmax. So let us move further. So we will now also have to define error for the three class case. So now defining error is not as easy as it was earlier. So here it was easy. I could just say if there is an error, so if this is detected and there is an error, so it is this probability which has an error. So it is just a binary case, because if this is not what is detected, then it should be this, because we just have two classes. So this is not as easy as uh, the case problem is not as easy as the case problem in case of error, because now here you have combinations. Now it can be possible that you have detected say you have detected this flower and its probability is 0.7, and but actually it was a sunflower. So you detected the flower with probability 0.7, but in reality it is a sunflower. So I am taking an image, it is a sunflower, but my algorithm is telling that the probability of flower is greater. So if I take the minimum of these, as defined in the two case problem. You take the minimum for error, then it will tell me this probability which is actually of the rose, which is again wrong. I want sunflower. So there is this problem that happens with the three or more cases class. So here you cannot directly give minimum of all is the error. So for that we now introduce a new term that is known as loss function. So basically it is a sort of a number which is given to a particular decision. So I'm giving each decision a number as to what, let us see what that number is. So first let me it so what is a loss function? It states exactly how costly is a decision. So what is my decision? So choosing a particular class is my decision. So here we had saw the decision rule. So here what is my decision rule? My decision is the whatever the greatest probability, you choose that class who has the greatest probability. So my decision is basically, here I am denoting my decision as alpha. So alpha means choose one. So it will choose one only when my decision rule is satisfied, which says that probability should be maximum of that class. So similarly, alpha 2 for 2 and alpha 3 for 3. So now I am defining my loss function like this: lambda alpha 1 given omega j. So what is this? This is not a probability. Basically, this is a number which I am going to give. So this is like this is something that the developer, the maker of the algorithm is going to give based on how my classes are. So first, what is omega 1? So omega 1 is a true value. So here in this I gave an example that actually it was sunflower, that was the true value, but it was detected as flower. So that will come in the case, say omega 2. So it was omega 2 in reality, but I chose alpha 1 because the probability of alpha 1 was high. So this is omega 1, this is what is reality in this expression. Basically what is the true case is omega j, sorry. So now how do I assign these numbers? So I can assign these numbers on mere observation. So here you can see, if I observe a sunflower and a flower here, so you can see a sunflower and a flower looks quite similar. So it is a good chance that sunflower and flower may be misinterpreted. So it is a good probability that a sunflower may be detected as a flower, or a flower may be detected as a sunflower. But a rose looks very different. See, the shape is very different. It is like this, and a sunflower is like this, and the flower is like this. So a rose looks very different. So according to this, I am going to assign losses. So I can see over here, I say given the same example, I am finding the loss. Lambda is basically loss. So what loss will I occur if I choose a flower but actually it was sunflower? So actually the real it was sunflower, really it was this sunflower, but due to the probability of flower came out to be maximum. So because these are very similar, so there is a good chance that you could have a loss over here. So I will define a larger number over here. Say I put a 0.7 over here. So this is basically a number that I am giving to tell that this has a lot of similarity, so that will incur a greater loss, is what I am saying. So lambda of alpha flower given rose. So basically here true is rose, and I am detecting flower, the probability flower. So because these are very different, the loss will be quite less. So because it is very less probable that this will happen. So, and if suppose lambda alpha flower, if it was detected as flower, given that it was actually flower, so the loss is 0. It was flower and you detected as flower, so big deal, it is actually true, so there is no loss that you are making. So these numbers are basically what the developer of the algorithm wants. So he will observe what are similarities between the classes and he can assign these numbers. So that is how this definition comes. You define how costly is a particular decision with respect to the reality. So now if we take a particular decision, say alpha I, let me take a decision, say alpha I. So say if we take alpha 1, I am taking decision in favor of flower 1. So this will be true if the probability of flower is greater than probability of sunflower and greater than probability of rose. So what all losses can I get? What all losses can I get if I use this decision alpha 1? So I am deciding it is flower. So let us see what losses can I get. So the first thing is that it is detected flower. I am detecting flower, but actually it was sunflower. So there can be a case that it is detected flower, but actually it was sunflower. So this will happen with this loss, that it was actually it was detected as flower, but actually it was sunflower. So this is the loss associated with this, and this is the probability of this being. So basically this is the probability of sunflower. This should be the actual value that I should have maximized, but then this is not happening. So this is the probability associated with it. Case 2, detected was flower, but actually it was rose. So here detected is flower, but actually it was rose. Omega 3 I am denoting as rose. So 3 is rose. Next, detected flower and it was actually flower. So true was flower and detected flower. So this is the loss associated with it. So basically this will be 0 and this is the probability. So which is right? This is what we get if this is the third case is right. Now in reality, say when I'm actually using this algorithm and I'm giving an image to the algorithm and asking I'm giving any image, so I'm giving this image and asking, I have done all the training, testing, everything I have done, and I'm using this particular algorithm, and I'm giving this image and telling the computer, tell me which class does it belong to, recognize, is it a flower, it is sunflower or rose. So in that case, I will not be knowing the true class. So I'm just given with the image and I don't know what is the true thing. So we may not know what is actual label, actual data or actual class basically. So hence what we can do is we can take the average of all these. So we just take the average of all this and we put it somewhere which we call it as risk. So this term risk is nothing but the average of all these classes. Why are we taking the averages? We are taking the average because we don't know whether the true will be sunflower, whether it will be rose or whether it will be flower. So we take the average. So the average is as follows. It is the loss into, so here say the risk for choosing an alpha I. So in specialty say I can say risk for choosing alpha 1 given a particular image, a given feature vector. So this risk will be nothing but the loss associated with alpha 1 if actually the real flower was sunflower with this probability. So loss of alpha 1 if we'll start from here. If it was actually flower, it was true value was flower and you get flower. So alpha 1 given the omega 1 into with this probability, that can be a case. Or the loss associated with, so in say normal situations we can put this as 0 because you know that there is no loss if it is detected what it was actually. So this will ideally be 0 in practical, mostly practical places, but then you can have different values. Then this is what is alpha 1. So what is the risk associated, the loss associated with alpha 1, that is decision of flower, given that actually it was true was sunflower. So that is the loss associated multiplied with this probability, and the loss associated with 3 multiplied with that probability. So this is the expected loss, but we gave it a nice name called as risk. So now instead of just calculating the probabilities, initially we had our decision rule. So we had used this discrete decision rule. Whichever is maximum, oh it is over here. Whichever is maximum, choose it. That is what we used to choose. Now what we will use is, since we have calculated this risk for all the three, so we will have risk alpha 1 given x, risk alpha 2 given x, risk alpha 3 given x. So we have these three risks. So what is the risk if I choose first class? What is the risk if I choose second class? What is the risk if I choose third class? So this is the new parameter that I found out. So now instead of comparing the probabilities, let us compare the risk, because it is more informative. It is giving us more information. It is also taking the information of that observation. So we found out these lambdas using observation. The developer who developed the algorithm observed these results and found out. So this is much better. So what we will define a new decision rule, and what my decision rule will say, it will say take that decision which has the minimum risk. So whichever class has a minimum risk, because I want to minimize the risk. So whichever class has the minimum risk, you assign that class. That is what I am saying. So my decision rule is now changed. I am telling now we will take a decision which has a minimum risk. Sorry, we are going for maximum probability in the earlier case, but now since we have introduced the loss functions and all sort of things, we have given new information. So we are using this risk now, and we are minimizing the risk because we want minimum risk. So here the decision rule will be choose 1 if alpha 1, the risk associated with alpha 1 is less than the risk associated with alpha 2, and choose 2 if vice versa. Oh yeah, alpha 1 it should be less than alpha 2, and it should be less than alpha 3. So risk of alpha 1 should be least, minimum, right? This is what we want. So this is the risk. This is my decision rule, my modified decision rule. So let us take an example. Say the risk of get risk of taking the decision in favor of flower. So deciding flower will be nothing but it'll be 0 into this, because the true value, if the true value is omega 1, so omega 1 is basically the true value over here, you can see. So if the true value is omega 1, then and it has detected omega 1, so means there is no loss. So it'll be 0 into a. Then this will be some number. So I had taken say 0.7 for sunflower, and I'm denoting 2 as sunflower. So here I'll have some 0.7 into this probability and some 0.3 into this probability. So what are these numbers? These are nothing but the lambdas. So this is lambda of alpha flower, that is 1, given that the true case is actually 1. Alpha 1 given that true case is 2, and alpha and the story. So this is what, and so we, by this we get the risk associated with flower. Similarly we can have risk associated with sunflower, risk associated with rose, and we'll see which is the minimum. I will assign the image to that particular class. That is what I'm doing. So now all these I did for 3 classes. I can generalize this for say C number of classes. So why 3? I want 4, 5, 6, many any number of class if I want. I can generalize it like this. So the risk in general will be the summation. So here there were 3, so it was from 0, C was 3 over here. So for n say C classes, so it will be from 1 to C. Say for 4 classes C will be 4 and the story. You are just multiplying the loss with the probabilities. That is what we are doing. And we see whichever risk is minimum for that particular decision, we are going to take that. So these are the notations. Here x is a feature vector. It can have n features. So initially we saw only 2 features. Here we saw only size and luminance. In the previous video you must have seen. But here we can have n features. You take size, you take luminance, you say take some edge, you say take some color, etc, etc, etc. You can have many these things. So to improve the algorithm, you can take many features. This is just to improve the algorithm. You can take many classes, so more the classes, more number of things it will be able to detect. You want to detect sunflower, any number of flowers, lily, etc. So that is, so says there are C classes. And alpha I basically is a decision, choose the ith class. Alpha I says choose the ith class. That is what. Okay, so let us specialize this to a 2 class case, and let us see what we had done for a 2 class case earlier. Is it in link with what we are doing now, or is it something else? So we will see that here. So for a 2 class case, what will happen is our C will be 2. Here C will be 2. So there will be addition of 2 things, 2 probabilities. So here I have given a new notation lambda 11 because it is easy to write that is. So lambda 11 basically tells you what is the loss that I am choosing 1 given that the true value is also 1. What is the loss that I am choosing 1 given that the true value is also 1? So this is alpha 11 into probability of 11 plus alpha 12. What is the loss with deciding 1 given that true value was actually 2? So this will give you the risk for choosing the first class. Similarly, I can have risk for choosing the second class. So what is my decision rule? We decide that class which has the minimum risk. So we will decide the minimum risk class. So let us say R of alpha 1 is less than R of alpha 2. So the risk with alpha associated with alpha 1 is less than the risk associated with alpha 2. If this is the case, I am just putting these values over here. So R alpha 1 given x is this thing. I have put over here, less than R alpha 2 is this thing. I have put it over here. So doing a little of algebra, taking lambda 2 term over here, taking this term over here, now taking this omega 2 common, and this over here common. So now we saw that if it is if the decision is 2 and the actual value is also true 2, so I am choosing say class 2 and the actual value was also class 2, or if I am choosing 1 and the actual value is also class 1, then my loss will be 0. There is no loss. You have done right, you have choose the right class, right? So this will be, let me take this as lambda is 0, and for a 2 class case, if I am choosing the opposite, I have the maximum loss. So the maximum loss can be denoted as say 1. So let me just plug in these values, and you see we get P of omega 2 given x is less than P of omega 1 greater than x. So over here, if the risk associated with alpha 1 is less, then the probability of one class, that is probability of omega 1 given x, is greater. So this is actually the specialization of what we actually used to do earlier. So we used to choose a decision rule whichever is greater, right? For the two class case, we saw decision rule, take the greater probability. So this just specializes to that. So that is what I say. So here this is a quite general case. You can take it for any. So the risk is quite general. You can take it for n classes, for any number of vectors, for and it is also giving some additional information about the observation that the developer is giving. So that is in terms of losses. So the different types of losses, the lambdas that we are choosing over here, that is defined by the developer. So this is giving additional information which is making the algorithm further better. So that was all for today's video. Thank you so much for watching. In my next video I am going to start with the normal distribution. So now in the next video we are going to see. So in the first video I had told you that the likelihood is a PDF, a continuous probability density function, and this is determined using the training data we had seen. So we will see, we will talk about these, and we will talk about different distributions that can approximate this in my further videos. Thank you so much for watching. Thank you.